Okay guys, gonna have a look here next at this dynamic mechanisms question from 2019 higher level. So we can see that OA there spins around anti-clockwise, and C is fixed and B is a pin joint and all that. So I'm gonna set that up there quickly. Okay, so I'm just gonna start this off here with a line for the ground. Now we know the center is up 68. And the radius of that is 48. So I will just draw that crank or rotating link there first. Now, the next thing we know is that over 115 horizontally from the center, I'll just heavy that in a bit. So over 115 is C. And I'm going to just mark 110 here now for setting my compass. So don't set your compass off the set square. So that's 110. Now the next thing we know is that the link here is at an angle of 60 to the vertical, which is 30. So this is the center O, that is A. Now, we know then, I set this to 110. So we know that from C to B is 110, and from A to B is 110. So that and our point P is in the middle of this, which is 55. So that's our setup, and I would heavy that in pencil. And I'm going to break up now this rotation into 12 equal pieces to allow us to drive on. And just to make life easier, I'm going to number this. So now, I suppose the thing to know there now is because C is fixed, C can only swing over and back, so B has to stay on that arc. Now there's two ways I could do this. One way I could do it, and I think it would be okay to do it, is if you just got a piece of paper, you marked in A, B, and here's P. So if one end goes to, if A goes to 1, B has to be on the arc here, and that's my location for P. Now I could just go along and mark all of them, and that's going to give me all the locus, and I could draw them, but that's using a piece of paper for the locus. I'm going to use the construction method with compasses instead. I prefer it. So first of all, if A goes to 1, it has to stay 110. So I'm going to just draw these one by one now rather than marking lots of them. I know it's a little bit slower, but so if A goes to 1, B must be here, and there we have it at 55. So that's P at position 1. So then it moves on to 2. So there's the link, and there is 2. So we can see our other method there was perfectly accurate to the millimeter as well, and so on. So I'm going to just mark there 3 and 4. I'm going too far ahead of yourself here is not a good move. So there's 3. And 4. So I'll just do these one at a time now, because at the end there it's easy to get confused when it's kind of at the end, just about to start going back in the other direction. So there's 5. 6. So it's just better to go slow and not screw it up than to mess it up and trying to figure out where you went wrong. So here's 8. So halfway is 55. 9, 10. And 11. Okay, so that's all the points I need for the full rotation. So I'll just grab a red pen. So that's 2 here. So it goes from P to 1 to 2. I'll just number 2 there. I forgot to number 2. Okay, so that there is our locus. That is the path of P as it spins around. So the next thing there then, so they asked to plot the locus P, which is the midpoint, for a full revolution, done. determine and indicate in degrees the maximum angle of rotation of the link CB. So what they're saying is, like, what's the furthest right to the furthest left here? What is the maximum angle for that? Okay, so as that spins over, we know that's the furthest it goes in one direction and the other one. So what is the maximum angle? Now, I suppose tricky enough in a way, but like as this link OA swings around here, what is the furthest right that B can go? Like how far to the right can this be? And I think one way you can find it anyway is if that's 48 for the radius, and we know that AB is 110, so if they were both straight here, if that OAB link was straight, it would be 110 plus 48, which is 158. So I could either mark it here, so that there would be 148. So if that entire thing was straight, that's where it would be. I think I will just put this in dotted there just to help you understand where this is coming from. Okay. I'll keep it in green now, I think. So that would be the furthest right that B can go. So I just mark that with a dotted line down here. And again there then, the furthest left that it can be then would be an extension of that to the other side through the center. So if that had flipped right around there, that would have A over here, and I'll just say there like that's A at the furthest point. And since we know that AB has to be 110, so when A is over here, I'm just marking that there, this is the furthest it moves to the left. So the extreme right is here, and that point there is the extreme left. So the angle here then, if I could find the protractor, 1 second now. So our angle there then is getting 51 to getting 52 degrees there. So 52 degrees is the angle of, that's the maximum angle of rotation. So I'll just put in a little arc there to show that. Now that is that question answered. But seeing as I just want to have a look here at something that comes up every now and again, and that is if you're asked to put a guard around a machine. And we weren't asked to do this. No, okay, we weren't asked to do this, but I'm going to put a guard around the machine here, just so that we can have a practice go at it. So now look, in theory you could just draw a huge box around it, and I suppose that would do, but I'm going to just use a colouring pencil here maybe or something. But I'm going to choose to keep the guard, just to have this looking well, I'm going to choose to keep the guard maybe 20 mil outside of most of the moving parts. So I'll just measure it here. Okay, that just happened to work out there being 20 mil. So what I'm going to do is I'm going to set my compass, and I'm going to say, alright, I would put a guard 20 mil outside of that, and I'm going to set my compass here to 20 mil here, and if I wanted to stay 20 mil outside of C, which doesn't move, and B above here is my extreme point, and what I'm going to do there then, I'm going to choose a colour for this there now. I'll just use a different shade of green. So I'm going to just put a tangent. Now you don't need to do a construction for this really, but so I'm going to put just a tangent there and another tangent between these circles here. And another tangent across here. And this is not usually the greatest idea. Now I'm going to do freehand circles, but I'm going to just complete this. And these and I'll just highlight that there, that the green is a guard. So there's no right and absolutely perfect answer, but like that gives roughly the same amount of clearance all the way around the moving parts there. So like that's something that comes up there now and again, and it's something that you should know about, should be aware of. So that is 2018. The linkages question. So best of luck with that.